Hello and welcome to yet another Linux podcast. This is your host Aaron, and today we will be going over the AMD Linux Graphics stack, its history, current state, and where it needs to be. First, some history on the Linux graphics stack. In the beginning, there was the X window system. It was the only user space application with exclusive access to the graphics hardware. If a GUI application wanted to display anything to the screen, it sent commands to the X server. The X server would receive these commands and translate them into hardware-specific calls. This translation is what a driver does. It takes hardware-independent commands as input and converts them into hardware-specific commands for the device it is written for. In the case of the X server, these are X11 graphics drivers, known as Device-Dependent X or DDX drivers. This approach worked well for 2D graphics, but for faster and more complex 3D graphics, it quickly became a limitation. 3D graphics hardware and libraries have existed in the Unix workstation space since the 1980s. However, they were all proprietary technologies and were designed to run on vendor-specific hardware. SGI was one of the Unix vendors that had a software suite called IrisGL that ran on their IRIX workstations. To promote cross-vendor support, SGI and other vendors such as IBM and Sun Microsystems began to develop an open graphics specification and in 1992 released version 1 of the OpenGL specification. In 1993, Brian Paul, a graphics hobbyist and IrisGL programmer, decided to build an implementation of OpenGL. Its early form was a CPU-only implementation, but it did support adding graphics hardware drivers to it. After negotiations with SGI to distribute it under an open-source license, he named the project MESA and released version 1.0 in 1995. It garnered a great deal of interest with several other developers working on it and is sending patches on a regular basis. By 1997, MESA was at version 2.2 and had its first consumer 3D hardware support in the form of 3DFX Voodoo card through the Glide library. However, it could not use the X window system, and the Voodoo card using its Glide driver would only support full-screen contexts and limited resolutions, and supported only a subset of OpenGL 1.1. In 1999, SGI published the GLX protocol as an extension to the X11 protocol. This allowed OpenGL applications to use the X server to send OpenGL render commands to the OpenGL drivers and conversely allow the X server to handle 3D graphics. However, developers soon realized that this approach was not good enough for intensive 3D workloads such as games. To work around this problem, developers at Red Hat and Precision Insight developed the Direct Rendering Infrastructure, or DRI. This required several architectural changes to the X server, MESA, and the Linux kernel. On the kernel front, a new subsystem called the Direct Rendering Manager, or DRM, was developed. This allowed more than one application to access the graphics hardware and provided the necessary command scheduling needed to do this. In the user space, the MESA project also switched to the DRI model. The X11 server drivers initialized the 2D graphics pipeline and then bootstrapped the new DRI drivers. OpenGL applications would create a window using GLX and then pass rendering commands directly through MESA using the DRI drivers. MESA and the X server could also do indirect rendering through the GLX protocol if there was no DRI compatible driver. The new DRI model was ready by the year 2000, with hardware support for the 3DFX Voodoo 3 and Voodoo 5, 3D Labs Oxygen, Intel i810, ATI Rage 128, and Matrox G200 and G400 graphics cards. While 3D graphics hardware was now affordable for open-source enthusiasts and developers to use and develop software for, hardware vendors like NVIDIA and ATI were a lot less eager about providing open-source drivers for their graphics hardware and instead released closed OpenGL drivers for Linux and Unix workstations. To counter this, developers and companies interested in having an open-source driver for their hardware started reverse engineering drivers for these consumer cards. ATI had an official Linux driver known as FGLRX. This driver, while it offered Linux support for ATI's graphics cards, was closed source and a pain in the ass to install and configure. Once installed, FGLRX was a buggy mess and was orders of magnitude slower than ATI's own Windows OpenGL Catalyst driver. In the meantime, several developers were reverse engineering an open-source Radeon driver for their ATI cards. The open source Radeon driver was even slower than the FGLRX, but at least was stable and could do some 3D rendering. ATI was acquired by AMD in 2006 and under the new management committed to monthly Linux driver releases and a unified development cycle. This saw big improvements to the FGLRX driver with much better stability and performance. AMD also started to release design specifications and documentation for older graphics cards, such as the Radeon 9000 series, for the open source driver to come up to feature parity and allow AMD engineers to focus on current generation support. The release of Windows Vista, with its new driver model, and DirectX 10 allowed AMD's driver development team to revamp their existing Linux driver support. In 2007, AMD announced a new open source initiative where they would release hardware documentation and specifications of their new R600 GPU, the HD2000 series. The open source Linux driver development was moving along at a rapid pace, and by 2009 had migrated to the then new Gallium 3D driver framework, which allowed both the Novu and the ATI R300 drivers to share a common code base where they could. By 2010, the R600 driver had also moved to Gallium 3D, and with MISA version 7.9, it had reached experimental status. In 2012, with MISA 8.0, Gallium 3D was the default for the Radeon R300 and R600 OpenGL drivers, and could support up to OpenGL 3.0. AMD's own FGLRX driver was still required for full OpenGL 3.3 support. In June 2012, Valve announced that they had ported the Source engine over to Linux and that they would bring their Steam distribution service to Linux. This announcement and the subsequent release of Steam for Linux on February 14, 2013, saw rapid driver development by both Intel and AMD to bring MISA up to speed. This spawned the dark age of Steam and Linux game ports. MISA 10.0, released on November 2013, only exposed OpenGL 3.3, while the new Linux games in development were targeting OpenGL 4 with the proprietary NVIDIA driver. Several AAA titles, such as Alien Isolation and The Witcher 2, only supported NVIDIA's proprietary Linux driver at launch. Rather than try to push game developers to support the FGLRX driver, AMD focused on getting their MISA R600 and the newer Radeon SI drivers up to speed. Vulcan was formally announced at GDC 2015, and in early 2016, the Vulcan 1.0 specification and SDK was released. By this time, the MISA drivers had more or less caught up with their OpenGL specifications, and by November 2016, MISA 13.0 was released with OpenGL 4.5 and Vulcan 1.0 support. The AMD VLK driver had been delayed by nearly a year after it was originally announced due to the developers working to integrate it with the existing LLVM shader compiler. During this time, the Linux DRM maintainer David Arley decided to build a Vulkan driver for AMD GPUs, as more Linux games were starting to leverage Vulkan, and several translation layers, such as DXVK, cropped up to enable Windows Direct 3D games to leverage Vulkan when run over Wine, which greatly reduced CPU overhead and improved performance compared to Wine's Direct 3D to OpenGL translation layer. Several other developers also started to contribute to the RADV driver, and it quickly became fast enough to run Linux games. By the time AMD released their own AMD VLK driver for Linux, game developers had already started targeting RADV instead. As of this video, AMD has the following graphics driver components. At the kernel level, we have the Radeon and AMD GPU DRM drivers. The Radeon driver supports all the older Radeon cards up to GCN 2nd generation or C islands. The AMD GPU driver supports GCN and now RDNA based GPUs. AMD has basically two OpenGL drivers. The open source MISA driver, which is default on almost all Linux distributions, and the AMD GPU Pro driver that is closed source and available for only select distributions directly from AMD. The Pro driver is an offshoot of their older FGLRX driver and is used mostly by ISV customers who need certified drivers or other specific application profiles for their software to work. For everyone else, the MISA drivers are the standard drivers, and most games and game developers now target the MISA driver for compatibility. The Vulcan drivers are even more confusing, with a partially closed source AMD GPU Pro Vulcan driver that uses a proprietary shader compiler, an open source AMD VLK Vulcan driver that is the same as the Pro driver but uses the same LLVM based shader compiler as that of the Mesa OpenGL driver, and the Mesa RadV Vulcan driver that was developed by Red Hat independently from the AMD VLK driver that AMD maintains. The current state of AMD's graphics stack is the culmination of years of effort from both AMD and the Linux community. Today, Mesa supports all of OpenGL 4.6 and Vulkan 1.1, along with several other OpenGL and Vulkan extensions. The R600G and Radeon SI Gallium 3D drivers also support DirectX 9 for older games running through Wine, and both AMD VLK and RadV are under active development. On the performance front, the Mesa OpenGL drivers perform as fast, if not faster, than AMD's closed source version, and have made Linux gaming a much more viable alternative to Windows. The AMD VLK and Mesa Vulcan drivers have also been steadily improving and can challenge NVIDIA's dominance in a few benchmarks. The AMD VLK driver that AMD maintains is fairly complex thanks to its source code being shared by both Windows and Linux. The main problem AMD has is lack of engineering resources when it comes to graphics hardware. Windows is still the dominant platform, and while support for new AMD hardware has improved in recent years, it is not as big a priority for AMD. The future of Linux gaming is heading in the direction of Vulkan. The DXVK project implements DirectX 10 and 11 over Vulkan and is used by default in Valve's Proton compatibility layer for getting Windows-only games to run on Linux. Wine developers have also been working on the VK3D project that translates DirectX 12 API calls to Vulkan API calls, so that newer games that support DirectX 12 can also work on Linux. There is also the Zinc driver developed by Collabora to implement OpenGL on top of Vulkan. Moving forward, AMD needs to work on getting their Vulkan drivers optimized for Linux games. Their AMD VLK driver is not very flexible when it comes to open source development, mostly because of its components being shared with Windows and other closed source platforms. To truly compete with the likes of NVIDIA in the Linux space, they need to streamline their Vulkan driver development. Fortunately, things are looking promising. The RadV driver is fairly well optimized for Polaris and Vega, and Navi optimizations are being worked on. The Radeon SI OpenGL driver is only one extension away from full OpenGL 4.6 support, and their AMD VLK driver, while not as widely used as the RadV driver, is seeing steady improvements. If you wish to support me and the work I do, you can sign up for a Patreon membership, which will give you access to my Discord server. And please like and share this video. Stay tuned for more of yet another Linux podcast.